Good day, everyone. So who does not want to increase operational throughput, optimize operations, and minimize CAPEX? So my name is Sylvain Gazaille. I'm the Chief Operations Officer at Simwell. So who is Simwell? Well, we're a modeling and simulation firm, engineering firm, comprising of about 70 people. We're located in Canada, United States. We have offices in Australia and India as well, and we're looking at expanding in Europe towards the end of 2024. Normally, when you're talking about optimization in models, people think about what is it for me? So picture yourself in a warehouse somewhere, or a supply chain situation industry, or perhaps port operations, and you've got burning questions, really complex questions to answer. Maybe you want to know, how many trucks do I need to actually meet my demand? How big do I need to increase my capacity for my building, given that I know I'm going to actually have more demand coming up with my growth? Perhaps you want to know what's the impact of losing very valuable human resources on your operations. Or perhaps you want to know how much it's going to cost me and reduce the risk of specific CAPEX, OPEX investment. Very, very expensive moving forward. Okay? So what we do is, right now, you're going to probably sit down with a bunch of subject matter experts, and you're going to come up with a number of potential solutions. You're going to zoom in on 2 or 3. You're going to use your Excel spreadsheets, your graphs, and you're going to actually calculate what that could look like. You're going to pick the best one. You're going to implement it. You're going to observe. You're going to actually take a look at the results, and you're going to readjust and go through that loop over and over again. With modeling and simulation, what we can do is we can actually sit down with you, look at your challenge, study the challenge together, and build a model, a replica of what that looks like in the virtual world. And once we've got that, then you can actually take these exact same subject matter experts, but instead of calculating numbers, you ask them, what are your most brilliant ideas? You take those ideas, you actually put them in the model, and in the span of a button, 5, 6, 7, 8 seconds later, you can actually have results. So you have the capacity to test hundreds of different scenarios, leading to the best potential solutions out there. So you're going to actually very quickly lead towards more returns on your investment. Now you're like, well, okay, Sylvain, you've got this great tool and whatnot. Can you do more for me? And the answer is absolutely. What we can do next is I can actually have my team of PhDs to look actually creating a mathematical equation to optimize your actually operation. So instead of having to try 100 different scenarios yourself, which is a significant improvement, you can now have a mathematical algorithm testing 1 million different scenarios, pointing towards the best potential solutions out there. Okay? So now you're going to have your optimized solutions given to you. You can decide to actually have a human in the loop to make the final decision, or you can actually integrate that simulation model with your optimizer into the real life operation, which we now call people call it a digital twin. That's what it is. And you can actually have the model give the outputs and commands directly to your machine to actually impact perhaps the flow of operations, the speed of a specific machine, to actually re-optimize your operations on the fly. So these are the kinds of things that we can do at Simwell. And if you don't have enough data to actually create your mathematical algorithm, what we can do is we can use a simulation model to take a look at a small data set to actually run 1 million times, create new data, variable data based on that small data set, to actually train your AI brain to optimize its system. So this is called machine learning. And all of that is done in a risk-free environment. So imagine the amount of time saved and money saved. So a few examples that I have here. Sorry. So here what you're looking at is a warehouse. And in that warehouse, you can see that there are actually trucks and forklifts moving forward and backward. You've got different types of materials stored in different areas. But if you take a look at the bottom of the screen, you've got toggles, little toggles to decide the number of forklifts that you want in your model. You can actually adjust any of the toggles there during the run itself, and then you can actually compare the results. So you can say, okay, what if I have 20 forklifts instead of 55? What's the impact on my processing time, my utilization, my queuing? What about my orders? And now what you're looking at is if this is implemented in the real life, you can actually see this all happening live and the speed that it is happening. So you can actually have an operational board that shows your operations and actually flags everything that's red that needs some attention. Better than that, if you have the right optimizer, they can actually self-fix themselves as time goes by and you are yet re-optimized. My second example is global supply chain logistics. So this kind of models, our client wants to know, where do I put my next distribution center? Should I put a big distribution center here or two smaller ones there? What about the number of trucks that I want if I'm trying to switch from diesel trucks to electrical trucks of different types? Where do I put them to minimize the CO2 impacts of all of the above? And in my last example, what you're looking at is a shipyard operation. That specific client wanted to compare different types of technologies to transport sea containers. So you've got different types of forklifts, different type of trucks. In the back, you see the different cranes as well operating. The sea containers are different color types for different types of material. And you also have the arrival of a train to study the impact of the arrival of a big shipment on your operation. So if you could add to this model, example, what about bulk materials, stockpiling, and in unconventional type shaped materials and whatnot. So on this slide, I would like to draw your attention to the solution on the left. One single model can actually be useful for multiple different types of people in your organization. If you're the operations manager, maybe you want to see a dashboard of all of the operations that is unfolding in front of your eyes. If you are a manager, maybe you want to make a CAPEX decision and you want to run different scenarios of different types of automated machines so that you can actually compare the results on your throughput. Or you can be the HR person, and you're trying to do some workforce management and trying to figure out how much people do I need to hire to meet my demand next year, so or next month. So I'm going to stop here. We are located at booth 1633, just there in the corner. And if you want to talk some more about potential solutions, I'm going to be more than happy to answer your questions. So thank you very much.